Hello everybody. So today we talk about the system design of Uber, and I will do the deep dive of scalability. So until yesterday, I talked about the high level design of Uber system, and also I talked about the matching process with the strong consistency on the matching, and also I talked about the geospatial index, and I decided to use Redis H3. So today I will talk about the scalability. So in non-function requirement, I specified scalable to 100 million data active users and 15 million writes per day and can handle spikes. So I will, discuss how my system can satisfy this number of scale. Yeah, so I will talk from three perspectives. So number one, throughput, and number two, spikes. So I can say the spike of the throughput actually. And also number three, from the storage size. Yeah. So that being said, let me get started. So I will do the barcode envelope estimation first. So I will write it here. Okay. So scalable to 100 million daily active users and 50 million words per day. So in terms of the throughput, I will take a look at the APIs. So we have these 5 APIs. And create for estimate, make request, fetch result, driver answer request, update location. Yeah, so I will pick up some of the most heavy loading APIs. Definitely the heaviest is update location because this is a kind of short polling. So each client, driver, and user makes the request to update the location. And because in the Uber system, the location has to be accurate and the driver moves around in a very quick speed with the car. So this is quite frequent one. So I will talk about this. And aside from that, maybe fetch result is also important because this is a short polling. Yeah. So for create fair estimate, make request for each ride, each of these are only called once, but for this fetch result, this is called multiple times. And for driver answer request, this is called maybe 10 times because one ride may take 10 drivers request answers. Okay, so that being said, I will talk about these 3 and 4 and 5 APIs. Sorry, let me talk about 1 and 3 and 5 because yeah, 1 is the most kind of gateway of the gateway of the writing matching system. So there are some users who leave the site after this and after this and after this. I'm pretty sure this is the this it's worth looking at this number. Okay, so as I said, I will talk about this API and this API. Oh, sorry. And number 5, this API. Okay, so number 1, create fair estimate API. So there are 50 million writes per day, so I can use this number. And 1 day is 10 to the 5 seconds. So in this way, I can get the 150 requests per day. So requests per sec. Yeah. So this is not a big number at all. So yeah, actually. Of course, this is right. So there are many users who would like to get the estimate and then finish it. But yeah, even if I include that, I can say maybe 3 to 500 requests per sec. Okay, so let me take a look. So this is the max request and the API gateway. This is fine because it's a cluster of servers, so it internally scales out. And for write service, this can scale out because the request is stateless. And for write DB, 150 requests per second is totally fine for PostgreSQL because it can handle for write request, it can basically handle 10,000 requests per sec. So this is totally fine. Okay, and fetch result. So as I said, this is the kind of polling. So we have 1 minute of the time for, up to 1 minute for each request to be accepted or in the end, ending with as a match. So I can say each request takes 1 minute times, let's say 5 sec, 12 requests per one write. So I can say 150 requests per sec, 12 is 1.8k requests per sec. Yes, so this is the fetch result throughput. So yeah, this is totally fine again. So in the same way, API gateway, this can scale out, write service can scale out. And for write DB, yes, 1.8k requests per second is totally handleable. But okay, let me write it here. So scale out with maybe auto scaling according to the maybe CPU usage, memory usage, or maybe number of traffics. And for this Redis, I can use the read replicas. So even though single PostgreSQL is fine, I use the read replica because this read replica also helps as the kind of fault tolerance. So even if the master node goes down, it can promote the read replica to the primary node. So yeah, this is not the scalability discussion, but I include these read replicas also for the fault tolerance. Okay. Now I will talk about the update location API. So this is the kind of most tricky one. So let's assume there are 200 million users in total. So 50% is daily active users. And let's say for each user, on average, okay, so this totally depends on user or driver. So let's say for driver, okay, let's assume weekly basis there are 100 million users and 100 million drivers available. So for user, I would say, I think the available, the users, the time user is using is, let's say weekly, maybe 3 hours. And let's say we make the request every 5 sec. So in this case, what I'm doing, so the user makes requests 36 times in a week. Okay, so 60, yeah, sorry, I'm a bit confused. So I said user is using 180 minutes a week. So okay, in a day, let's say on average, each user is using 10 minutes. So in a week, it becomes an hour and 10 minutes. I think this makes sense. So okay, in a day, so 10 to the 5. But I divide this by 5. because so there are 5 times per minute. Wait, sorry. So 10 minutes. Each user uses 10 minutes in a day on average, and every 5 minutes this is done, so 2 times in a day on average. Okay, so 100 million user makes 2 times of request a day, and 1 day is 10 to the 5 seconds, so I get it in this way. So 200 requests per sec. Okay. Yeah, okay. Let me change a little bit. This is too small. Let's say each user on average uses 50 minutes. Am I correct? What am I doing? Sorry. Because on average, each user, let's say each user uses an hour a day. Okay, in this case, there are 12 an hour a day in this case. Yeah, this times. Okay, because, sorry, so if user uses an hour, I have to divide an hour, which is 3,600 seconds, by 5 times, by 5 sec. So I get 720 times. Yeah, so this is it. Okay. So with this, it becomes 1K. Yeah, I think this is it. So yeah, this much. Okay, 720K requests per sec. Okay, so for driver, let's say user uses, let's say, on average 3 hours a day. So this is 3 times, so 2 million requests per sec or something. Okay, this is quite a lot. Yeah. Okay, so this is a number throughput or update location. So this is so much, even though API gateway and location service can handle this, because let's say, I would say each location service, okay, so sorry, I mean, in total, it's around 3 million requests per sec or something. Okay, so it is possible that API gateway handles it, location service can handle it by scaling out, because each EC2 server can handle around 1,000 requests per sec, so we need 30 servers. Yeah, which is a realistic number. And for Redis, this is a kind of tricky part. Okay, let me search the number quickly. Okay, so I searched it quickly. So according to the Gemini, so 1K to 10K requests per sec for the update query. And for search query, oh, sorry, this is wrong. This is 10 to 100, and search is 1 to 10K. Okay, so this means that, okay, for update query, because I'm talking about the update query, so it can handle 10K to 100K. So this is much smaller than this 3 million requests per sec. So I can do the Redis kind of sharding, I think. So yeah. And also, okay, so let's say I use this number 100K. We need 30 I mean, nodes. I need this Redis server to be scaled out with 30 servers. So what I can do is, let's say the drivers in the US is definitely doesn't have anything to do with drivers in the US, sorry, drivers in Japan, and also the same way, the drivers in Japan are not related to drivers or users in Europe, or maybe even in the Europe, the drivers in the UK is not related to drivers in the France or Italy. So I can do the sharding by the location, or actually the continent. So that's something I can take here. So for Redis, I use the sharding by location, sorry, continent. Yeah, so that's something I can do here for Redis. Okay, so definitely it was a good idea that I don't put this location columns in this user table, driver table, because this is quite heavy. Okay, and that being said, I still can reduce this number because maybe driver is, stopping at the stop traffic light. In this case, the driver's location has to be updated. So I can use adaptive polling here. Same for user. If user is, of course, searching for the ride in his house, the location doesn't have to be updated. So according to the distance from the previous location, yeah, this can decide. Each client should be able to decide how frequently the location should be sent. Yeah, so that's what I mean by adaptive polling. Oh, and maybe I should talk about the scalability of a request worker. So for request worker itself, this can be scaled out. Of course, one server can open multiple processes to handle multiple requests with one ride per one process basis. But of course, this can scale out. So, this CDC is a kind of queue. So, internally. So, CDC is sent into the queue, like Kafka, and this is consumed by request worker. Yeah. So what I can say is, for this Kafka, I can use the sharding, or I should say partitioning. So I can specify the partition key. I can use the write ID because each write is completely independent to each other. So yeah. So in that way, each partition has writes, and I can increase the number of workers who work on each partition. Because obviously in Kafka, if I create the partition, there is only one consumer group. Sorry, there is one consumer who can work on that top partition. So yeah, I need to scale out. Yeah, and there I can use multiple request workers. And for each request worker, okay, so across all the request workers, so how many queries there are? So because there are how many? Sorry, 15 million writes per day, and each write matching takes, let's say, 10 requests. Yeah, because it firstly gets the nearby driver locations, and then every 5 sec it makes a request and check if the driver is available or not. So if the driver is found, it doesn't have to make 10 requests, but if driver is not found, it has to make up to 10 requests. So let's say on average it makes 10 requests. So there are 100 requests writes per sec, and this takes 10 requests, so it should be 1.5k requests per sec. Yeah, so for this, 10 requests comes here, but for the, there's only one request to Redis. Okay, so this is the request to this database, especially driver, checking the drivers, status. Yeah. And for this one, because it has to, hit only once, so I don't need this, and I get 150 requests per sec. So this is completely fine. So as I said, Redis can handle 1k to 10k requests per sec for search queries, so this is totally fine. And for PostgreSQL, yes, this is fine because as I said, it can handle 10k to 50k requests per sec. Okay, so I discussed the scalability about the throughput. So I will talk about the case of the spikes. So if there is a spike, all the paths for this, is, many more. This becomes many more. So let's say we have 10 times of spike. So because I wrote here, create first estimate is 150 requests per sec. But let's say there is a concert in the stadium and there are 10,000 requests per sec. 10,000 people would like to make the request in 1 minute. So in that case, it's around 10 times more. Yeah. So because 10k in 1 minute. So this is around per sec. So 10 times. Yeah. So in this case, what happens is that the throughput to this write DB becomes 10 times. And actually this is still fine. Oh no, but for the create fair estimate query, this is fine because 1.5k is completely handleable by one PostgreSQL primary node. But for fetch result, this times 18k, and this is still fine because 10k to 50k requests per sec is handleable by PostgreSQL read query. But as I said, I use a read replica so that read queries are, handled by multiple nodes. Okay. And update location. This actually doesn't change, or maybe it does because there are maybe many drivers around the stadium because they know. But actually this number doesn't change because, okay, sorry, I think this is a kind of tricky. So spike here doesn't mean the spike all over the site. The spike in the specific area. What kind of changes does it make here? Yeah, maybe what I can say is for Redis, okay, so what I can say is, let me repeat. So for spike, yes, there is a spike, but it doesn't mean the create fair estimate becomes 10 times because it's the, kind of spikes in the specific area. So this doesn't become 1,500. Yeah, obviously. But even with 1,500, it's fine. For fetch result, the same way, it doesn't become 10 times. And because the requests are handled by multiple servers and it is stateless, so even if there are so many requests specific to some area, it is, routed into multiple servers regardless of the location. So it doesn't create the hotspot. Yeah. Samely for this Kafka, because I made the write ID to be partition key, there isn't specific hotspot. Same for request worker, I can say. Only possible hotspot is Redis, because I scaled out. I shared the Redis with the longitude continent. Yeah. So, but that being said, update location of driver is 2.60 million. So this 3 million becomes a bit more. Yeah. But I think this is a big number because when I compare this number and this number, it increases only 1,000 requests per sec. It means that if there is a concert and let's say it ends and within a minute 10k users at the same time request a ride, it increases 1,000 requests per sec. So which means that we need, because I'm talking about this. Sorry, so yeah, same. So update query increases 1,000 and also search query increases 1,000 because each ride leads to the one search query. Okay. So how can I handle this? So the thing is, just same as the, sorry, it's the same as PostgreSQL. I can use the read replica. So master replica architecture. Yeah, or I should say replication. So just to be clear, so sharding by continent, I can say this is Redis cluster. So I use the Redis cluster. But with Redis cluster, which means that sharding, I also use the replication. So master node data is asynchronously, replicated into the reader node. So for search query, this Redis cluster can handle more queries, but there is a kind of time lag because it's the eventual consistency. But it's around, it's up to 1 minute, I can say. So what happens is maybe request worker fetches the driver's locations nearby the user with the 1 minute old data. But this is fine because driver doesn't move so much in that 1 minute. Even if they move so much, they can come back in 1 minute. So yeah, I can accept the eventual consistency of the master replica synchronization in Redis. Yeah, so I use the replication. Okay. For update location, of course, this has to be written to the master node. So yeah, this driver's location. Yeah. So what I can do is maybe the server decides to drop some requests of the location if this Redis is really kind of overloaded, because location is updated after 5 seconds. So yeah, I think it is acceptable that, let's say, I put the queue, asynchronous queue here. Okay, sorry, so one possible approach is putting the queue here, right? Kafka, and the worker, there's a worker I abstracted. Sends the request to Redis cluster. So my kind of my idea is, yeah, I do this, create this async queue by the partition key user ID. So the same user ID's location is consumed by the same consumer. So that consumer can do the deduplication if there are multiple location update requests for the same user. The latest one is used. So in that way, even though the frequency of the location update becomes less frequent, I can kind of mitigate the load. So that's something I can do, I think. Okay. Okay. And for this request, there wasn't a problem, but yeah, if this heavy rows, I can use the same thing. I can put the async queue and worker and do the bulk write to the database. So in this way, the request per sec, I mean, let's say the worker is, consumes the job every 3 sec. In that case, of course, because of the batch write, the load to the database is reduced. Okay, so there's something I can say about the scalability, especially for throughput and spikes. Okay, and something I have to add about here. So one thing I have to take care when introducing Kafka is Kafka's consumers operation is at least once guarantee. So it is possible that the same message is processed more than once, like twice, 3 times. So to handle this, I need the idempotency key. So let's say frontend creates the kind of key UUID, which is used as the idempotency key and included in the request of create fair estimate. And then write service write it into the queue, and the worker fetches a message, and yeah, of course it passes that idempotency queue to fair estimate service, and fair estimate service makes sure that multiple writes are not created. And also same for PostgreSQL, I would include kind of idempotency key to the fair estimate table and also request table, and make sure that same request is not made twice. Yeah, so because I'm talking about the, what is it? So post request, especially for create fair estimate and make request, it should return OK status if the record with the same idempotency key already exist. Yeah, so that's something I can say. Oh, sorry. So no. Wait. Oh, sorry. No. Because create fair estimate and make request becomes now asynchronous API. So it should just return 200. But internally in a service, we have to make sure that multiple records are not created. It doesn't have anything to do with the HTTP response. Okay, but for the worker here, it's totally fine, even if the same. Okay, the order of the message handling is guaranteed within the partition key, within the same partition key. So even if the worker processes the same message twice, it doesn't occur that older message is handled after the later newer message. So this worker doesn't have to consider the duplicated message. Yeah. What happens is just worker updates the database location data with the same record, which is totally fine. So it's a not critical problem here. But for here, I have to make sure that it uses the idempotency key. Okay. Okay, so now we'll talk about the scalability from the storage size. Yeah, so I will write it down here. So we have PostgreSQL and also Redis cluster. So when I take a look at the database, user table, driver table, I'm almost pretty sure it can be stored in the same single PostgreSQL because obviously this is, currently PostgreSQL, let's say AWS Aura, can store 500 terabytes of data, and if the table is for each 100 bytes or something, so it's I think gigabyte order, so it's totally fine. I will just write it. So 100 bytes for each user data or driver data, and there are, let's say, in total 200 million users. So with this, byte becomes kilobyte, megabyte, gigabyte, and 20 gigabyte. Yeah. So this is totally fine. And for fair estimation table, request table, driver response table, match table, this is a kind of tricky because this is incrementally increases historically. So I will think how many rise in total in a year. So this should be 15 million times 365. So this should be around 50. So yeah, around. Wait, I'm okay. 15 times 365 is around 5,000. So it should be million, billion, 5 billion writes per year. And let's say I will take a look at, something like request table. So there should be 5 billion, and let's say each data is 1 kilobyte. So this basically corresponds to match table, request table. I'm talking about the order. I don't think about the match rate or driver response average number or something. Just in general, I can say. So this should be billion is 10 to the 9. So kilobyte becomes megabyte, gigabyte, terabyte, 1 terabyte. Yeah, this is still quite small, I can say. So even with 100 years, it becomes 100 terabyte. And as I said, AWS Aura, which is PostgreSQL, can store 500 terabytes of data. So I don't need the sharding of this WriteDB. Yeah. But yeah, I think in my idea, I can completely separate the data between across the continent for two reasons. Number one is scalability. Yeah, fault tolerance. Yeah. Oh, sorry. I can say this is from security reason. Sorry. So because the users' data, drivers' data in Europe should not be stored in America or in Japan. So I can do the continent level sharding. And it was because of the security perspective, or I should say data security perspective, but we also benefited in terms of the storage and scalability too. Yeah, good. And for the Redis cluster, also I'm pretty sure this is totally fine because user data is updated. So I can say each user's data is, let's say, 100 byte. Yeah, even with 10 bytes it's fine. And let's say there are 200 million users. So as I calculated here in users table, it becomes 20 gigabyte divided by 10 is 2 gigabyte. Yeah. So Redis stores only 2 gigabyte. And even more, we will do the sharding. So storage perspective, Redis cluster is totally fine. Okay, so now I talked about the scalability of the storage too. Okay, that being said, I finished my today's practice. Yeah, I talked about the Uber in the last in 3 videos, yeah, in total. So yeah, thank you so much. Bye.